Okay, so in this video, we're going to take a look at finding the magnitude and the direction of a vector. All right, so magnitude and direction of vector. Okay, all right. So as we saw earlier, we're going to take a look at a vector in the standard position vector. All right. So we're going to define here, let's say this is vector v with terminal endpoint here at some point r, right? So the point itself, right, has coordinates x1, y1, right? But again, that's just point r. The vector v is that whole arrow right there, the magnitude and the direction. All right, so we're going to define two quantities here. The first quantity is the magnitude, or the length. So the magnitude, we'll use this notation, right? The absolute value, as we're used to when we're dealing with numbers. But here we're dealing with vectors. So when we take the we call it the magnitude of a vector, right? So here that symbol is read as the magnitude of the vector. And notice here, what comes in handy is our trigonometry here. Because if we think of the length here, well, we have a right triangle here, right? Where we have length along the horizontal x1 and along the vertical y1. So applying our Pythagorean theorem, we see, all right, well, the magnitude of this vector will be x1 squared plus y1 squared. Okay, so again, notice this will always be a positive value regardless of where x1 and y1 happens to lie, or of which quadrant it happens to lie. Okay, so here we have that to be our magnitude. Now our direction is going to be, so direction will define now as the angle made with the x-axis. Called angle theta made with the x-axis. Okay, all right. So usually we'll refer to the positive x-axis, but this could also, depending on applications, right? There's no kind of standard to kind of that we have to be holden to. So maybe it's the negative x-axis, but that will be explicitly stated, right? So when we refer to direction, we'll make sure to state that it's with the positive x-axis or the negative x-axis, or in rare occasions the y-axis. Okay, but for now we'll just think of it as the angle made with the positive x-axis. All right, now in terms of equality of vectors, so can I tell? I know how two numbers are equal, right? One is equal to one, but how do I know that two vectors are equal to? All right, so well, u and v are equal. We use the same equal symbol, all right? All right, so now that we define magnitude and direction, well, u and v are equal if they have the same magnitude and direction. And the direction. All right, that's important as well, right? Because they could have the same length but pointed in different directions. All right, also, so additionally, if they have the same position vector, if u and v have the same position vector, then they are equal. Okay, so now we've defined vector equality, right? What does it mean for two vectors to be equal? Okay. All right. So let's work out an example here. So for this example, I want to find the magnitude and the direction of a vector with initial point P, -8, 1, and terminal point Q. Q, -2, -5. Okay. All right, so now that's what we start with. All right, so let's what I want to do here is I want to have the standard position vector. So I'm going to define V. All right, so ideally we're looking at the vector PQ, right? But here, dealing with them in space is kind of challenging if I want to use the formula set above, right? So initially, what I'd like to do is put these in standard position. All right? So the way that I do that, and I know that based on here, if they have the same position vector, they're going to have the same magnitude and the direction here. So V, I'm going to define as, again, using vector notation, Q is my endpoint, so we'll have -2 minus -8. All right, watch our signs here, and then -5 minus 1. All right, so we get the vector, what is this, +6, and then -6. Okay, so drawing this vector out in standard position looks something like this, right? We get 1, 2, 3, 4, 5, 6, 4, 5, 6, -6, something like this. So that is my vector V. All right, and then here, direction would be this angle theta. All right, so that's just kind of a quick sketch of my vector V, right, which has the same magnitude and direction as the vector PQ. All right, so let's start with the magnitude of V. So V, here the magnitude, we take the components, 6 squared plus -6 squared, right? So we get magnitude of V to be equal to 36 plus 36, which is equal to √72. And let me, here this is actually 2 times 36, so I'm going to rewrite this as 6√2 in its simplified form. All right. Okay, so there we go. That is the magnitude of my vector. All right. Okay, so now let's take a look at the direction, right? Now the direction is the angle here, right? So again, my right triangle trigonometry is going to come into play here, right? So I know here this value is x1, this value is y1. So I can relate, because those are the values I know, I can relate the tangent of theta to be equal to, right, y1 over x1. Right, and that point here is in fact 6, -6. All right, so tangent of theta is equal to, well, -1, right? Plugging -6 over 6 reduces to -1. And this actually is in my unit circle angle. So theta, here, if we take it in the cloud, so I can call this angle using the negative, in a negative rotation. If you want to do the positive, then again, that's a different angle here, but relative to the positive x-axis, the angle here is going to be -pi/4. So now I've found both of these quantities here, the magnitude and the direction, right? And that is what defines a vector, right? Both of those things, magnitude and direction.